Hello everyone, welcome back. In this video, we're going to talk about the sampling distribution for X bar. So in the previous video, we talked about a sampling distribution for p hat, okay, describing how a sample proportion behaves. Now we're going to try to describe how a sampling distribution for X bar behaves. So how does a sample mean behave? Okay, how does the sample mean behave? So these slides are going to look very similar to p hat, just to give you some continuity about what the differences are between X bar and p hat. So when we have questions that have that are answering, or sorry, if we have questions about the sample mean, we have actually three pieces of information that we need to know. Okay, and so those are the population mean. Okay. Again, we need to know for these kind of questions what the population looks like. All right. So if I were talking about the mean height of all people in the United States, I would have to know that beforehand if I want to use a sampling distribution for X bar. Okay. And so if I knew that, then I could answer questions about the sampling distribution. So we need the population mean. We also need the population standard deviation. Okay, so the population mean is the symbol mu, and the population standard deviation is the symbol sigma. And then third, we always need the sample size. So we need mu, sigma, and n. All right, and so the sampling distribution for X bar, or how X bar behaves, is just like p hat, approximately normal. Okay, specifically, it looks like this. Okay, X bar is approximately normal with a mean of mu and a standard deviation of sigma divided by the square root of n. Okay, so we have different symbols than p hat, but it's basically the same thing. Okay. Again, the previous slide is only true when certain conditions are met. So just like p hat, there are certain times where the distribution of X bar is not going to be normal. The condition that we need to meet this time is actually not as challenging as the one for p hat. Okay? The condition this time is that the sample size needs to be greater than or equal to 30. Okay? And there's actually something behind these conditions. There's like a mathematical formula or a mathematical idea, specifically a theorem that drives all of this stuff that we do, and it's called the central limit theorem. Okay, so this n greater than 30 condition is often called the central limit theorem. Okay, now that statement that I made is not necessarily true in all cases, but it's good enough for us. Okay, and so if you're ever asked questions in the homework or something else about the central limit theorem, you should know that's the n greater than 30 condition. So if n is greater than 30, then you can use that normal sampling distribution for X bar that works because of the central limit theorem. Okay, is basically what I'm trying to say. Now, again, these conditions, or this one condition, needs to be met in order for you to actually use that sampling distribution. Okay, and if you know the sampling distribution, then we can use it to begin to answer those questions posed at the beginning. All right, great. Now there's another app that I want to show you and that you should definitely explore that describes a sampling distribution for X bar. So we had one that sort of looked at p hat, specifically the coin flipping example, and now we have one here that describes the sampling distribution for the sample mean. Okay, so I will enlarge this a little bit here. Okay, in every question that we do, we always have what's called a parent population. Okay, how something behaves in the real world. Okay, and so what we're doing when we're taking data is that we're taking a small sample of that population. Okay, And so what we're going to do here is I'm going to take the mean, so I'm going to sample from the population, which is what we do in real life, and then I'm going to find the mean of those. And so you want to look at these three graphs, or these three plots. This plot, this one, and this one. And so I'm going to take the mean of, we'll start with 10 numbers, okay? The mean of 10 numbers. And so I'm going to take a sample of size 10, so you'll see me taking samples there, and then they find the mean of that number and bring it down here. And so we can do that again. And again, we have it there. A third time, just for fun, there. And then I'm going to speed it up and do that 100,000 times, okay? And so when I do that 100,000 times, you get this plot. And if we were in class, I would ask you, what does this plot look like? What kind of shape does it have? And you should answer, it looks normal. Great, okay? And so there's sort of the idea of when I take the mean of a bunch of numbers, that mean is described by a normal distribution down here. They even have where you can fit a normal curve, so you can actually put the curve over the histogram, okay? And so you'll see that it looks normal. Now, that condition says that we looked at before is no matter what your parent population looks like, okay, as long as you have n sufficiently large, the mean will still look normal. So let's change it to something. This is actually if the parent population is also normal. Okay, we're going to change it to something different. We're going to change it to a skewed distribution. Okay, so now you see that the parent population is mostly to the left, and so we would say that this is actually skewed right, okay, from earlier in the class. When I take a sample of size 5, something small, okay, and I do that 10,000 times, you'll see that the distribution, the histogram, looks mostly normal, but it's a little off from where the curve is, okay? But if I increase, so that's maybe not so normal with n equal to 5. But if I increase it to something closer to 30, maybe say 25, and then I take 10,000 samples again, you'll see that although it's not perfect, the curve fits the distribution a lot better, okay? And so you'll see that it looks more normal than the one previously. And in fact, you can do a distribution that looks skewed. They actually allow you to do a custom distribution. So maybe I have some distribution that looks really weird here. Okay, so that's a really weird distribution. And still, if I have a mean high enough of 25, and I take a bunch of samples, you'll see that the distribution of the mean down here still looks pretty normal, okay? And so that's what the sampling distribution, that's what the central limit theorem says, okay? And that's how we get the sampling distribution of x bar, okay? It always comes out looking normal. So we'll go back here and do a quick example of this. Again, I won't be able to show you StatCrunch at the moment because it's not behaving for me, but I will show you it and actually an alternative to it, Minitab, in a later video. So, according to the 2010 U.S. Census Bureau current population survey, the average number of people in a household that contains both family and non-family members is 4.43, so it has a mean of 4.43 and a standard deviation of 2.02. Okay, great. So there's the population mean and the population standard deviation. Okay, and so we'll believe that because it's from the census, which attempts to sample all people. Okay. Suppose that I took a random sample of 225 people just from anywhere. Okay. That's my n. So I ask, what is the sampling distribution of x bar? Okay. And so simply what you're going to do is you're going to substitute in these numbers that you have, mu, sigma, and n, into the formula from a few slides ago. And when I do that, I get this. Okay. And so you'll see on the left-hand side, I haven't done the math yet, and then I do the math on the right-hand side. Great. Are the conditions met? Is n greater than 30? And the answer is yes. I took a sample of size 225, which is greater than 30. Great. So I didn't check that there, but of course you do need to check that before you can use the sampling distribution. And so then I ask, again, a question I cannot answer at the moment. What is the probability that I would see a mean of at most 4.2 people? Okay. Again, this is a question that you've basically already answered in lesson 4. I have a normal distribution right here, okay, over, well, my cursor's not there, but I have a normal distribution. I know that x bar is normal with a mean of 4.43 and a standard deviation of 0.135, okay, and I can find a probability, okay, of at most, which means less than or equal to 4.2, okay? And so you have the tools to do that. So here's a reading assignment that further talks about the sampling distribution of x bar, okay? And here's a your turn. Again, it's just like the your turn from the p-hat question, but here's another example that you can try and that the solution is up on D2L. Okay, so I'll see you next